Here we go, video 7.4a. We're going to take a look at formula mass and molar mass of different compounds. Basically, in this video, we want to look at our chemical formulas and what those tell us, as well as how to find the different masses of those chemical formulas using the periodic table. Quick review here of few important terms here. We're really looking at how do we represent particles, knowing that when we are talking about a molecular compound or a molecule, that means it's a covalent compound. Remember, this is going to be between a non-metal and a non-metal is a covalent compound. Ionic compounds, the word formula units is always associated with an ionic compound, which is a metal plus a non-metal, so that's important to know as well. If we're talking about just a little individual ion, so something with that plus or minus charge, we're just going to label that an ion. Specifically, this one, a positive ion, cation. Remember, cats purr, they're positive, and the anion is your negative ion. And of course, if you are just given an element, that we can consider just as a single atom is a single element on the periodic table. So let's look at here the formula mass for a specific compound. Basically, all you're going to do is add up all of the atomic masses of the elements in the chemical formula. Well, first and foremost, we need the chemical formula. So here we have potassium chlorate. We've learned by now with our naming rules, potassium there, it is going to be a +1 charge. Chlorate is one of our polyatomic, ClO3 with a -1 charge, plus and a negative balance. There we go, we are good on our masses there. Now we need to use the periodic table to get the atomic mass of each element. So if you actually go to your periodic table right now, find potassium here, it's going to have a mass of 39. Chlorine over here has a mass of 35.45. So then we can go back here to our problem and solve our problem. Potassium there, again, a mass of 39.09. Chlorine, we said, was 35.45. And then my oxygen, I know it's 15.999. I'm going to round it up to 16 times 3. I have my subscript 3 here. And I'm going to add up and then multiply to get my final answer. Adding them all up, we get 122.54 as my final answer. And that would be grams per mole. Because if I look off the periodic table, each one there is going to be in its really AMU state. But if I'm given 1 mole of this compound, if I had 1 mole of potassium chlorate, then I know that 1 mole of any element on the periodic table equals its atomic mass in grams. So that's how I can give it the grams per mole unit. Or you could label it AMU in that case. If we scroll down here a little bit further and look at molar mass, now that is where you must use the grams per mole. This is dealing specifically only with the mass in grams of 1 mole of a substance. Or you have those 6.02 times 10 to the 23rd particles of that substance. So here we want to find the molar mass of water. So I know water, I hope everyone knows H2O. And hydrogens, I have 2 of them. Each one has a mass of 1.01 AMUs. And I have 1 oxygen, its mass is 16. So I add those up and I get 18.02 grams per mole for the molar mass of oxygen. That's specific to 1 mole. If I just wanted the formula mass, then I could label it as 8.02 AMUs, where we use those atomic mass units for formula mass. Let's look at one final example here. molar mass barium nitrate. Well, I know barium is right here. It's going to be a +2. Nitrate, NO3, and it has only a -1 charge. I need to balance the charges, so I have barium NO3 2. I need to get the atomic masses of each one of those. Go to my periodic table. Barium, I'm going to find it right there, has a mass of 137.33. Nitrogen is 14.01. So barium is 137.33. Go back to our problem here, dealing specifically with barium, 133.33. 137, I believe, 0.33. Go back and double check that. 137. There we go. Nitrogen is going to be 2 of them. I need to distribute my 2 all the way through to both. So it's going to be 2 times 14.01 plus 6 times 16 for my oxygens. Add those up, and we get 261.35. Again, I'm looking for the molar mass, so that's grams per mole as the mass of my barium nitrates.